Howdy ho, folks. Today we're actually doing a pretty fun section. You're going to like it, I promise. It's 9.3, and we're factoring this. And it'll make more sense as we get into it. But yeah, we're factoring things of the form x squared plus bx plus c. So before we get started with that, remember this is way back from the last chapter before spring break, but we need to multiply these two binomials together. So we learned a technique to help us do that. Remember, I've got a binomial, two terms, so I'm going to make a box that's 2 by 2. I'm going to put the x plus 7 on top and the x plus 8 on the side. And now in each box, I'm going to put what these two things multiplied together is. So x times x is x squared. Now I need to write it all out. All of these are positive, so they're all going to be added together. And I notice I have some like terms. 7x and 8x is really 15x. All right, so our final answer then is x squared plus 15x plus 56. So let's look at this one. This one says, Brad multiplied two binomials together and got this as his answer, x squared plus 10x plus 21. Can you find the original binomial? So they gave us the answer, right? They gave us this, and they want us to find this, but it's not going to be x plus 7 and x plus 8. Pause the video right now and see if it actually actually try it. It might take you a few minutes. See if you can find the answer. All right, did you get it? So here's a little hint if it helps you to think about it like this. Remember, if we have x here and x here, that means this one is our number, so this one must have been 21. So we're looking for, well, what two numbers could we have multiplied together to give us 21? There's not a whole lot of options here. Really, the only option that we have is, well, it could either be 1 times 21 or it could be 3 times 7. And let's double check that the rest of this works. So this would be x squared, this would be 3x, this would be 7x. All right, if we write this all out, then yes, we get x squared. And then we combine these like terms, 3x plus 7x is 10x, and yes, we have that plus 21. So we actually found it, right? It's x plus 3, and it's x plus 7. Or you could have had these reversed. It doesn't matter which order you have it in. So that's what we're doing today. This is called factoring because we're undoing the distribution, right? We're undoing the double distributing, and we're finding what the original factors were. So let's do one more. It tells us to factor, so they want us to find the original two binomials. Pause the video and see if you can figure it out. See if you can figure out what those factors were. All right, so this time we had a 14 here, and again, we still don't have a lot of options. What times what could have given you 14? Well, we could have either done 1 times 14, but if we do that, they're not going to add up to 9, right? Or we could have done 2 times 7. And sure enough, if we do 2 times 7, we get 2x here, we get 7x here. Ah, yes, because 2x plus 7x does give us 9x. So these are the correct factors, 2 and 7. So this is the factored version. So first thing you need to write down, remember that factor means to undistribute, but here we're talking about double distributing. So if they say factor, that means go from this back to the original. If they say distribute, they mean go from this to the polynomial. And then next, here are those steps for what we just did. So if they give us the answer, essentially, the whatever x squared plus number x plus number. Remember, b and c are really just going to be numbers. Here's what we do. So notice that it puts a letter here instead of a number, right? They're saying list all the factors of c. C is actually going to be some number. So maybe it's 14, maybe it's 21. We're going to look at that last number, and we're going to list all the factors of that number. We're going to find the pair of factors whose sum, remember sum means addition, is b. And then when we get those numbers, we're going to write it out in this form. So pause the video and finish writing this down. All right, let's do it. Take a second and copy example 1 down. So I'm not actually going to draw out the whole box this time. I'm just going to follow those steps that we just wrote down. So step 1 says list all the factors of C. C is the last number. So I'm looking at 36. So I have a few options here. I could do 1 times 36. I could do 2 times 18. I could do 3 times 12. Ooh. I could do 4 times 9. And I could do 6 times 6. If I keep going, I'm just going to end up repeating. So that's all of them. Step 2 said, find the pair of factors whose sum is B. So which of these add up to give us 13? Well, it's not these ones because 1 plus 36 is 37. That is not what we want. It's not these ones. So which is the correct set of factors? Which one adds up to 13? Yeah, it's this one right here because 4 plus 9 gives us 13. So this is the correct set of factors. So our answer then, step 3 says write it in factored form. We're going to put our two numbers where they go. It's going to be x plus 4 times x plus 9. All right, so how do you think you check that your answer is right? Well, you got to multiply it back out. You have to double distribute everything back out. So I'm going to do that using the box technique real quick. All right, and sure enough, when I multiply it back out, I get x squared plus 13x plus 36, which was the original thing that we had. Awesome. So that means that this is the right answer. Example 2 is the same type of problem. Please copy it down and try it on your own. Okay, so once you have all your factors listed out, you're looking for which ones add up to 11. Sure enough, it looks like it's 5 and 6 this time because 5 plus 6 is 11. So our answer then is x plus 5 times x plus 6. You might have had the 6 written first. It doesn't matter. You could have x plus 6 times x plus 5. And there we go. There's our right answer. To double check it, I'm going to do my box method. I'm going to multiply these two back out and make sure that I get the original back. And sure enough, 5x plus 6x is 11x. And then we have that plus 30. So yep, we get the original answer back. Awesome. Okay, example 3. Same thing. Pause the video. Try them on your own. When you're done, I'll have the answers up here and you can check. Okay, these are our answers for both of these guys. Now on this one, if you were listing out your factors and you got 2 times 12 written down and you saw right away, oh, that's it, because that adds up to 14. No, you do not need to keep listing all these factors out. Once you see that you have it, you can stop right there. You don't need to keep going. And those are our factors this time, 2 and 12. This one, okay, there weren't a lot to choose from, but I'm willing to bet that your answer did not look like this. So what happened here is they were both 5s, so it was really x plus 5 times x plus 5. And then I noticed, hey, I'm actually multiplying the same thing times itself. I'm really doing this times itself, the same thing. So the better way to write it, if you have the same factor twice, is to just put that factor once and say we're squaring it, because square just means times itself. So if you ever have the same factor, put it in this form right here. All right, so far all of the problems that we've done were all positive numbers, right? Everything is a plus sign, which is nice, right? But our answers weren't always positive when we were multiplying them out before. So what if we have one that looks like this? It's actually not too much different. So I'm going to start out the same way. I'm going to look for factors, but instead of looking for factors of 8, I'm going to look for factors of negative 8. So I could do 1 times negative 8, or I could do negative 1 times 8. Do either of these add up to give me 2? No. So I got to keep going. It's not one of these. It could be 2 times 4, or one of them has to be negative. It could be 2 times negative 4, or it could be negative 2 times 4. And finally, here it is. It's this bottom one because negative 2 plus 4 is 2, positive 2. This one was negative 2, which is still not what we wanted. So it's this one right here. So our factors this time are not both going to be x plus. One of them is negative, so it's going to be x plus, and it's going to be x minus. The positive number, the 4, goes after the plus sign, x plus 4. The negative number, the 2, goes after the minus sign. All right, what about this one? And this time I have factors of 50, and it's positive again. But here's the thing. I see that they're going to need to add up to a negative number. So if I start by listing out, oh, well, to get to 50, I could do 5 times 10. There's no way that 5 plus 10 is going to be negative 15. But I do see that 5 plus 10 is 15, so I'm actually pretty close. So how could I change this where when I multiply them, I still get 50? Well, so 2 positives give me a positive, but I could also make both of these negative, right? I could do negative 5 times negative 10. And sure enough, negative 5 times negative 10 is 50. But when you add them up, you get negative 15. So this time, these are our factors. So this time, they're both negative. So I get x minus 5 and x minus 10. And just to show you guys that it's right, we're going to multiply this one back out. All right, and then after I combine my like terms, I do indeed get x squared minus 15x plus 50, which was our original polynomial. So yes, this is right. All right, so here's what we need to do if it's not all positive numbers. You need to check if the last number, the c, is positive or negative, and you need to follow these steps. So yeah, this is kind of a lot, but you need to get this written down in your notes. So pause the video to do that now. And we're going to get 2 examples written down where it's not all positive. The steps are really pretty much the same. So I'm still starting off by looking at this 6. It's positive 6. But I noticed that the middle number is negative this time. So let's look back at our steps. It says check if the last number is positive. Okay, it's positive. That means the factors have the same sign. So they're either both plus or they're both minus. Look at B, the middle number, to tell which it is. So they're either both plus or they're both minus. Look at the middle one. Since it's a minus here, they're both going to be negative. So factors of 6. Well, I could do negative 1 times negative 6. Remember, we said they both have to be negative. I could do negative 2 times negative 3. And that's it. So these are all my options. Which ones, when I add them up, gives me negative 5? Well, it's these guys right here. Negative 2 plus negative 3 is negative 5. So these are my correct factors. So I'm going to write it like this. X minus 2, x minus 3. Now I'm going to check my answer by double distributing it back out. X negative 2, x negative 3. And yep, I got the same answer back, so my answer was right. So this is indeed the correct set of factors. Last one. So this time I'm looking at my final number. It's negative 18 this time. So those steps said, if your last number is negative, then the factors have different signs. That makes sense because a positive times a negative is a negative. That's the only way you can get a negative 18. So one number is going to be positive and one's going to be negative. So I could do 1 times 18, or 1 times negative 18. I could do negative 1 times 18. I could do 2 times negative 9. I could do negative 2 times 9. All right, do I already have the correct factors written up here? When I add these up, does one of these factors have a sum of negative 7? Yeah, actually one of them does. It's this one right here. 2 plus negative 9 is negative 7. If you add those together, you get negative 7. So that means that since this one is positive, it's going to be plus 2. Since this one is negative, it's going to be minus 9. And for good measure, I am going to check my answer. All right, so when I add like terms, 2x minus 9x is negative 7x. And then I still have this minus 18. All right, awesome. Yep, we got the same answer back. So that means our answer is right. I told you this was a fun section.